Hi, my name is Shubh Maheshwari. I am a researcher at TCS Innovation Lab and will present our paper Transfer4D, a framework for frugal motion capture and deformation transfer. This is a joint work with Professor Rahul Narain and Ramya Hebbalaguppe from IIT Delhi. Motion capture is the process of animating a virtual character based on an actor's real performance. This is a challenging task, currently requiring expensive motion capture setup and additional effort by expert animators, rendering it accessible only to large production houses. In our work, we attempt to democratize animation transfer by replacing these expensive setups with a single view depth sensor, and to automate animators' effort in laborious rigging and motion transfer steps. Unlike previous approaches, our aim is to generalize to a wide variety of characters of dissimilar shape, without the use of parametric body models or supervision. Our approach is category agnostic and can be used not only for humans but also for animals, birds, and other articulated objects. Transfer4D is a generic framework for transferring motion from a single view depth video to a user-defined target mesh. We aim to democratize content creation by replacing expensive mocap setups with a single view depth sensor and by automatically rigging characters to transfer motion. We use a single depth sensor, thus our input only captures the frontal view of the source object and can be noisy. Furthermore, the user-defined mesh might not contain a predefined skeleton rig. This makes our approach frugal, enables mass market reach, and is more practical for deployment. However, shape matching between sparse source and complete target shape has not been explored extensively in the literature for non-humans. Prior works on deformation transfer make a stricter assumption on the source to be noise-free and watertight. Given a depth video, we first perform non-rigid registration to align the source object at a canonical frame to every other frame of the video, thereby obtaining its trajectory. Then, during skeletonization, we use the geometry and the trajectory information to extract the underlying skeleton structure and its motion. In the skeleton embedding step, the obtained motion skeleton is embedded inside the target mesh and skinning weights are calculated for deforming the target mesh. Finally, for motion retargeting, the rotation of the bones is transferred from the motion skeleton to the embedded skeleton. To align the source object, we require a skeletonization method that does not require markers or predefined template and works on single view incomplete mesh sequence. We propose a novel skeletonization approach that helps in motion transfer by reducing artifacts that arise solely through motion skeletonization. To achieve this, we construct the motion skeleton using the structural cues of the curved skeleton extracted from local separators. Notice that the extracted joint position from local separators lies on the surface of the incomplete mesh. Our optimization aligns the joint position to the medial axis of the object. To incorporate the motion information, each curve of the extracted curved skeleton is split into multiple bones. More details can be found in our paper. Compared to skeleton extracted from static skeletonization methods, by utilizing motion information, our method produces temporally coherent skeleton. Unlike other skeletonization methods, by incorporating structural cues, ours is more effective at embedding the skeleton from the incomplete mesh sequence. Next, we show the results from Transfer4D. The motion of the source object is shown in pink and the deformed user mesh is shown in teal. Note, our NRR implementation does not perform any volumetric integration during motion capture. Thus, actions with 180-degree rotations like spinning or turning cannot be captured. Our use of Pinocchio leads to a limitation that the source and target shape should be approximately in the same pose. We presented Transfer4D, a pipeline in the direction of unsupervised animation transfer from a single view commodity sensor to virtual characters. We propose a novel skeletonization approach that helps in motion transfer by reducing the artifacts that arise solely through motion skeletonization. More details can be found on our project page. Thank you for listening.